So I wanted to make a quick video to go over my solar system. This system is installed in my vacation home. I'm going to show you all the different components and how I set it up. It's been working flawlessly for the last 6 months. It was installed in August 2024, so that's almost 8 months now. So I'm going to show you what's in there, what I used, and how I connected everything. Hopefully somebody can benefit from it. So the system basically comes with a 5.5 kilowatt of solar panels. So I got 10 550 Canadian Solar Bifacial. I don't really get a lot of benefits from the bifacial part because it's very close. As you can see, it's very close to the roofing, so there's no reflection from the bottom. And the reason I put it too close to the roofing because of the amount of wind that we get up here in the mountain area. So as you can see, I have 10 panels. 5 of those panels are on one string, and the other 5, which is 4 right there, and then 1 here, those are one string. Both of them are feeding through the conduits here. So this is one string coming in, the other string is coming in here. Both of them are coming through the wall, and then they come on top of the roof, then come down into the disconnect switch. The disconnect switch here is basically the IMO, and it is UL rated. Haven't really got a chance to use it much. It's just for emergency only for now. I have another disconnect box that's come as close to the inverter because this installation here is on the 3rd floor, and the actual inverter is in the basement. So one more thing I want to mention here is when I installed it, I used those mini rails. So those mini rails come with the base part that gets nailed into the metal roof, and then the second part is a spacer, and then the third part is the clamp that clamps the solar panel to the rail. There's 2 different clamps. One is the end clamp, which is the 90% angle, as you can see here, and that is, so that one on top is the 90% angle. That's for the end panel, and then you have the other one, which is a flat, this one right here. That is actually the connecting between 2 panels together. So this is the current setup that I have, and I basically designed it and built it myself, and installed it with some help from friends. But as you can see, that I have a junction box that's in here that has all the connections from this panel and the other 4 panels into that box, and it runs down to the conduit and comes here to another junction box that combines both strings together to go down to the inverter. The second string, as you can see here, and it comes with 2 lines. Those are all connected in series, and the other string is connected in series, and they're connected through this junction box. Basically a pass-through box. There's nothing in there besides just be able to disconnect the panels if I need to. So I had to create a J box for that. So as you can see, they're connected here together into this box, and then going up to the inverter. So when it comes to the basement, this conduit here is the smaller one, the bigger one. This one is what comes from the roof, solar panel, the wiring, and I'm using just a standard AWG 10 gauge wire. It's coming from the roof. Everything that's inside the conduits is 10 gauge wire. Everything is outside. I'm using solar PV wires. So it comes down here into this control cabinet. This is where the inverter and everything is in here. So as you can see here, I have MPP Solar inverter. This is a 6500 watt inverter, and it has been running really well. It's a kind of older technology, so the controls and all the stuff are kind of manual, but it's a pretty solid inverter. Honestly, I'm very happy with it. And the reason I picked it because it had a lot of good reviews. Unfortunately, I bought the older version that is 250 volt PV max, which I'm actually almost maxed out with the 2 strings. So each string produces about 230, 240 volts. So I'm almost at the limit of the input, the 250 on per string. So as you can see here, the inverter gets 2 strings. So the PV lines come from down here from the roof, comes into the disconnect box. So this disconnect box comes with fuses, 1 for each string, and then those are in-series fuses. And those, I believe it was 30 amp fuses, I can't remember. But then I have another disconnect switch here. And that disconnect switch allows me to disconnect for service. I bought this from Amazon. I can put links for everything that I bought here in the description. But that should be sufficient to do what I want. I try not to disconnect it under load. So if I need to disconnect, I normally would disconnect the inverter first so I don't have I don't disconnect under load and cause sparks. Then I have in parallel, I have 2 different. So I have those surge protectors. So those surge protectors actually serve. So in case if I have lightning or something like that in the solar panels, they get dissipated. Those are connected to the house ground. So as you can see, there's a green line here, and that green is connected to the main ground of the main breaker panel. Everything is grounded through one ground, which is at the front of the house, but it is the same ground as the AC side. So the DC side ground is connected to the AC side ground, and all of them are connected to the one ground rod. The PV comes down here, it gets connected to the fuses, and from the fuses to the disconnect switch, and then it goes into the surge protectors here. That brand that I bought is a little special brand because it's a DC250. What's in the market? Most of the ones in the market are 1,000 volts and 500 volts, and I choose this one because it's 250. So I wanted to make sure that even if I get the surge, I'm not running 1,000 volts into the inverter. I'm running 250 into the inverter. So I looked at this online. It was very hard to find ones that are 500 or 250. So if your inverter can max out at 500 volts, then you need to buy a surge protector that has the UCP, which is that number here, UCPV 250. Otherwise, it's going to be useless. If you have a lightning or something like that, it's going to pass whatever that voltage number into your inverter. So if your inverter can't handle more than 250, then you need to stick with something that offers you maximum 250. Otherwise, you're going to burn the inverter in case of an accident. So this is what I have here. It comes out of here. PV1 and PV2 go into the inverter, and then the inverter has the battery connected. Both batteries are connected here. So I have 3 sets of batteries, 5.2 kilowatt hour each. That gives me 15 kilowatt total. That's enough for about 2 days of usage, or a day and a half to 2 days of usage, in case if I have 0 sun during those days. So those are the batteries. Pytes batteries, I think they're one of the top quality. I've had 0 issues with them. Their support is great. I contact the support if I have any questions, and they're very helpful people. So I recommend them to use. I don't know, I don't have experience with other manufacturers, but Pytes the reviews that I've seen before I bought them and the experience that I've had since I bought them has been excellent. So those are the Pytes V5. Those are the newer version. I think they're coming up with another version soon, but as you can see, I have them connected. As you can see, I'm connecting the ground to the top and the positive to the bottom. That way it balances them out. Another thing that I have here, so I have an external generator that's connected to this thing here. So it's a backup generator that's capable of providing emergency power in case if I have 0 power, 0 solar, and 0 battery. So I have an external generator. The generator is actually, I connected a SmartGen controller, which you can buy any brand. All of them, most of them do the same thing. This is the cheapest and most basic one. So this one basically takes the dry signal. So I'm connecting normally on, normally open with this. So you can see it from here. Those are the dry signals that comes from the inverter, and it comes down to give the signal into the generator, into the controller, and the controller gives the signal, the start signal, to the generator. I can do another video to how to set it up. Basically, once it gets the signal, it triggers the start sequence. So the start sequence, it will give the signal to the starter, and it will start for 3 seconds, and then it will disconnect, wait for it to start. And if it doesn't do that, it will keep repeating that same process until it starts, or after that, if it doesn't start after 4 or 5 attempts, depending on how you set it up, it will give you an alarm, and it will not continue to fire up the starter. So this has been working really well. So I have it currently set up to start when the battery goes to about 10%. So if I have 10% battery level, this one, the contacts will trigger the controller, and the controller will trigger the start of the generator. And it goes up until I have it set up up till 25% battery. That way it's not running constantly all night or whatever. It just goes between 10 to 25%. That's how I have it set up. I also am using that a trickle charger that's connected to that feeds the power to the generator controller, and also it connects to the battery of the generator that is continuously keeping the battery charged at 14.5 volts. So that is an important thing for me, because this house is unattended. I'm not here all day to charge the battery in case if I have an emergency I need to start the generator. So I have this trickle charger continuously charging the generator battery, so it will be starting at any time. In addition to this generator controller, I have a Wi-Fi module that is connected to the generator, so I'm able actually to start it remotely using my Wi-Fi in the house from across the world. I'm gonna show. I have like a small video to show the remote controller that I'm using, and the remote controller is actually I bought it from the internet, and it works on both with a button remote control or an app remote control. The app allows you to remotely control that, and you can program the controller, the remote controller, which is using this app called Tuya or something. I'm going to share that description down below, and it allows you to set up the sequence. So I have it set up when I click on the start button remotely on the app, it will trigger the starter to run for 3 seconds and until the generator starts. So it's a pretty neat feature. It allows me to start the generator even if I'm across the world, and make sure that the house doesn't run out of batteries. So this is kind of the setup that I have, and then the AC side of things. So the AC conduit that comes from here comes to a main breaker. This is a 60 amp breaker, I believe. So 60 amp. I'm running one phase one, so 120 volts. This is a single phase inverter, but if I wanted to, I can replace it with a 220 two-phase, and I'm gonna, in this case, I'll use both sides of the breakers to disconnect both phases. So when it comes out of here, it comes out of this conduit, it goes to the breaker box. So this conduit here, the one on the left side, that goes straight to the main breaker box. So this is in a nutshell what I have here. And if you have any questions, leave it in the comment and I'll be able to answer it. But that's kind of summary of my system. I'm not promoting MPP Solar or any of this stuff. I'm just telling you what I have. MPP Solar is a good, solid inverter. It's made by Voltronics, which they make different brands, so MPP Solar is one of them. However, the support of those has not been the greatest. I think it used to be 24/7 watt or watt 24/7. That was one of the dealers, and they have other dealers as well in the U.S. But in my opinion, the factory support has not been the greatest. Anytime you have a factory support that is not local in the U.S., first, you're not going to get the same customer service level that you get in the U.S. because their definition of customer service is different from what people think in the U.S. Some people in Taiwan or China don't understand how to deal with customers and be nice and supportive to them. And then that's one thing. The other part is they are 12 hours behind. So every time you need something, you send them an email, you have to wait for either 1 or 2 days before you get a response back. So if you're in a bind and you have an emergency or you need a response right now, you're not going to get it. So my recommendation is buy something that has local support and have somebody that will give you local, when I mean local in the US. So I know that Focus is using the same inverter as well. And I actually asked them questions because they have the same the same inverter, and I've been getting really good support from them, even though I don't have their inverter. But they are very responsive, very professional. I'm not promoting them, but I'm telling you, if you're looking for something that's done by or made by Voltronics, another version of that would be Focus. And some other brands, but Focus has a lot of presence in the U.S. and they have a lot of customer support in the U.S. They're not a dealer, but they are a brand owner, so they are different than you buy just from online vendor. So that is kind of my 2 cents on the inverter side. If I would go back, I would have bought either Focus or I would have bought something like EG4 or something like that that has local technical support than just buying MPP Solar. MPP Solar may used to be good when they had a good dealer network in the US. Right now they don't, so they're selling direct, but unfortunately all of their customer support and technical support happens from Taiwan, which is very far away, and the cultural difference and the way they respond and understand the questions, it's different. So talking a little bit about the generator. So the one I have here, I actually have 2 of them, but the one that's connected to the controller is a Predator 3500. It's an inverter generator, and I prefer to use that because it's actually an inverter generator, so it works better with the inverter. Then it gives you better frequency than the standard generator. I have the standard generator, which is 8,000 watt, or I guess 8,000 watt, yeah. But it's just a standard generator, so I prefer to use that with the inverter, so avoid any issues with the signal or the backup signal that's coming into the inverter. This is the out box, the connection box. So this box is actually behind the inverter, where I showed you the cable that was coming out. And this is an extension cord that connects directly to here. So if I want to, I can take this off of here, connect it to this one here. So this is how I set it up. Behind this is the controller. Like I said before, I have two ways of starting this generator. One through the SmartGen controller that takes the dry contacts from the inverter, and then it feeds into the starting. It gives the starting signal, the choke and the start connected together. There's a lot of videos you can watch about remote starting this generator, and you can do that same on this one as well. But the way it's done, you get a signal, you get a start signal, and it goes to the starter, and the choke itself. The choke actually have an actuator that's connected to the choke that operates from the starting signal. And then it also has the kill signal. So when the kill signal comes, it disconnects the magneto on this thing, and it disconnects it for 8 seconds until the generator fully stops. So I can make another video about this later, but this is basically the signal cable that's coming from here. It also has the battery charging. So if you look at those wires here, the black and red, those are the battery charging. So it kind of trickle charges the battery. It also feeds the wireless controller that's behind this panel here, the wireless controller that you control from an app. I'm going to show you a picture in a video a little bit, and I'm going to add a little video to show what it looks like. But so the black and red, those are positive, connected to the battery terminals as well. The white and the green, those are the start and stop signal. And then the yellow and the blue, those are the feedback, the 120 volt feedback from the generator to the controller to let the controller know that the generator started. So that's the setup that I have here. I hope that was helpful to somebody. And if you have any questions, let me know. I'll be able to help you out. Thank you and enjoy your day.